Hey guys, a few days ago you found out what a Taylor polynomial was, and now you're going to use Taylor polynomials to find Taylor series. First, you see a recap of what a Taylor series is. Something funny is going on here. Okay, and then we're going to create the Taylor series for f of x equals e to the 5x centered at x equals 2 using that formula that is in the box above. So if you're asked this on the AP exam, you can see that it's pretty simple. You just pop it into the formula, and that formula really isn't that hard to memorize. You're going to be using it so much that you probably won't have to even struggle to memorize it. But it is important to remember that, I'm sorry, I'm distracted, that you need to write it in a particular way with the general term at the end. So here we go. Oops, that's kind of messy, isn't it? There is, well, it's still messy. Oh well, just pretend. There are the first four terms, 1, 2, 3, 4. And then at the very end, you have, funky monkey. Okay, I'll just stick with that. You have the general term. And this is how it's written with the ellipses in the middle and the pluses on either side of the ellipses. So there you go. Prior to the AP exam, you absolutely must memorize the series for e to the x, sine of x, and cosine of x. So we will first derive a series for e to the x, then derive a series for sine of x, and then finally derive a series for cosine of x. With those three series, we manipulate those series. You're not expected to regurgitate those three. You are expected to be able to manipulate them. And when you get to the next page of your notebook, you will see us start to manipulate them. And also in your homework, you will be manipulating these three series. So when we derive a series for e to the x, we just look at the original function, the first derivative, second derivative, third derivative, and then we create a general term. We use the Taylor series formula to create it using f of x plus f prime of x times x divided by 1 prime plus f double prime of x times x squared all over 2 factorial, etc. And that will be true for all x, an element of the real numbers. Or, as I said in Benin, x appartient de real. Boom. Next, we're going to derive a series for the sine of x. And it will actually work similarly to e to the x. These should not hurt your brain. Perhaps putting them in the formula will. It is kind of difficult at first to remember the formula. Once you've got that formula down and you've done enough homework, hint, hint, you should be fine. So if you look here, first I discovered or figured out what f of 0, f prime of 0, and f double prime of 0, and f triple prime of 0 was, and then wrote out my Taylor series. I usually actually skip this step right here, What just happened, y'all? What was that craziness? Okay, I usually skip this step right here. And then you can quickly figure out that every other term is canceling because every other term up here is in fact 0, which might be a little bit confusing to some of you, but most of you are going to be like, oh, I get it. Okay, so let's see. I'm just trying to find a pretty color. Okay, so when you look at this, you can see that this is going to be 0. This is going to be 0. See how every other term is 0? So you can very, very quickly figure out your pattern. So I did not anywhere above create this term, but I can intuit that is the next term in the sequence. I don't know if you need this many terms. Usually you'll only need 3, but you will almost invariably need the general term. And that general term will usually be pretty easy to figure out. There it is. Okay. So that's all we've got for that. But this is true for all x an element of the reals. So in class, we completely skipped deriving that series. If you would like to derive that series, you are more than welcome to. It is not very difficult. However, you do want to make sure that you understand how we got to the cosine x thing here, because you may actually forget these during the AP exam. And if you forget these during the AP exam, it's really not that hard to come up with them on your own. So if you do not understand how we got here, please come up here and work it out. Okay. From here on out, you're going to manipulate these series. You will use manipulation techniques by substituting into the series, multiplying or dividing the series by a constant or a variable, dividing or subtracting two series, or differentiating it or integrating a series. So we're going to start by finding the Maclaurin series for f of x equals sine of x squared and giving the first four non-zero terms in the general term. We already know what f of x equals sine x is, and we're going to replace all of our x's with x squared. So here we go. Here's the sine of x, the Maclaurin series for sine of x, and we are going to replace all of our x's with x squared, and then we will have a Maclaurin series for the sine of x squared. Once you replace x with x squared, you can create the general term. In addition, you can now also integrate the sine of x squared because you have a Maclaurin series for it. Before now, in order to integrate the sine of x squared, you would have had to have used your calculator, and it would have had to have been a definite integral. With that in mind, we're going to do something rather lame, and we're just simply going to differentiate that Maclaurin series so that we can find f prime of x. So here you see the Maclaurin series for the derivative of sine of x squared, and I made some errors, so I'm going to fix those very quickly. So if you look, this bit right here was incorrect. That should have been -1 to the n times x to the 2n all over 2n plus 1 factorial. Then on this next step, this should have been 4n plus 2. So there was another mistake. Boop. Make sure you fix that in your notes. So that should read -1 to the n times 4n plus 2 times x to the 4n plus 2 all over 2n plus 1 factorial. Then this final expression is correct. I just got confused in my notes and was looking at the wrong place. So when I come back, which will be in hours, but in your view will be seconds, I will find the Maclaurin series for f of x equals x cosine x, find the first four non-zero terms and the general term. Then I will integrate it, which you were not I think you would have had to have integrated by parts in order to do x cosine x, but now you can use a Maclaurin series. Doo-doo. So we're just going to take our cosine x series and multiply that whole thing by x. So multiply each and every term in that series by x. Easy peasy, pumpkin squeezy. And all I did here was multiply the entire cosine of x, the entire Taylor series for cosine of x by x, and got the following the following Maclaurin series. And remember that a Maclaurin series is a specific kind of Taylor series centered at 0. A Taylor series is not a Maclaurin series, but a Maclaurin series is always a Taylor series. Now we're going to integrate that using an indefinite integral, and we're going to find the first 4 non-zero terms and the general term. So when we integrate that Maclaurin series, we get the first 4 non-zero terms and the general term, and it looks like this. It should be fairly clear what's happening. However, I just realized I made a mistake in in A. For some reason, I cannot count, and you only needed the first 4 non-zero terms. So go ahead and fix that, and make sure you count when you take the AP exam. And that is all we learned on Friday.